Welcome to the brand new section, Learning Object Classification. We'll be first introducing machine learning concepts, then move on to computer vision and the machine learning workflow. After that, we will see automatic object inspection classification example, and lastly, feature extraction. Now, we move on to the first video of this section that deals with introducing machine learning concepts. Here we will look at how machine ML algorithms learn from the data or samples. Also, we will see some categories we obtain from machine learning algorithm, depending upon the desired results. We will go through some methods and approaches used in machine learning. We will also learn about OpenCV in detail. Machine learning is an old concept that was defined in 1959 by Arthur Samuel as a field of study that gives computers the ability to learn without being explicitly programmed. Tom M. Mitchell provided a more formal definition. In this definition, Tom links the concepts of samples or experiences, labels, and performance measurements. Machine learning involves pattern recognition and is related to computational statistics. Machine learning is used in hundreds of applications such as OCR, optical character recognition, spam filtering, search engines, and thousands of computer vision applications that we will develop in the current section, where a machine learning algorithm tries to classify the objects that appear in the input image. Depending on how machine ML algorithms learn from the data or samples, we can divide them into three categories, which are supervised learning. The computer learns from a set of labeled data. The goal is to learn the parameters of the model and rules that allow computers to map the relation between data and output label results. Unsupervised learning. No labels are given, and the computer tries to discover the input structure of the input data. Reinforcement learning. The computer interacts with a dynamic environment that performs its goals and learns from its mistakes. Depending on the desired results that we obtain from our machine learning algorithm, we can recognize them into four subparts. Classification. In classification, the space of the inputs can be divided into n classes, and the prediction results of a given sample are one of these training classes. This is one of the most used categories. A typical example is an email spam filtering where there are only two classes, spam and non-spam, or OCR, where only n characters are available, and each character is one class. Regression. The output is a continuous value instead of a discrete value, such as a classification result. One example of regression can be the prediction of the house price by providing the house size, number of years, and location. Clustering. The inputs are divided into n groups using unsupervised training. Density estimation. This finds the probability distribution of inputs. In our example, we will use a supervised learning classification algorithm, where a training dataset with labels is used to train the model, and the result of our model is a prediction of one label. Machine learning is a modern approach to artificial intelligence and statistics and involves both the techniques. In machine learning, there are several approaches and methods, and some of them used are SVM, support vector machines, ANNSs, artificial neural networks, clustering such as k-nearest neighbors, decision trees, or deep learning, which is a big neural network approach, used in some cases that are convolutional, and so on. All these methods and approaches are supported, implemented, and well documented in OpenCV. We are going to explain one of them, SVM, in the next section. OpenCV implements 8 of these machine learning algorithms. They all inherit from the StatModel class: artificial neural networks, boost, random trees, expectation maximization, k-nearest neighbors, logistic regression, the normal Bayes classifier, support vector machines. To get more details of each algorithm, read the OpenCV document page of machine learning at link. In the image, you can see the machine learning class hierarchy. The StatModel class provides all the read and write functions that are very important to save our machine learning parameters and training data. In machine learning, the most time-consuming part is the training method. Training can take from seconds to weeks or months for large data sets and complex machine learning structures. For example, in deep learning and a big neural network structure with more than 100,000 images. In deep learning algorithms, it is common to use parallel hardware processing. For example, GPUs or graphic cards with the CUDA technology used to decrease the computing time during training. This means that we cannot train our algorithm each time we run our application, and it's recommended that we save our model after it's trained because all training prediction parameters of machine learning are saved. Next, when we want to run it in the future, we only need to read from our saved module without training anymore if we need to update our model with more data. The StatModel is an interface that is implemented by each of its implementations. The two key functions are train and predict. The train method is responsible for learning the parameters of the model from a training dataset. The train function has the following 4 calls that can be called in 4 different ways. Train data. This is the training data that can be loaded or created from the train data class. This class is new in OpenCV 3 and helps developers to create training data because different algorithms require different types of structure of arrays for training and prediction, such as ANN algorithm. Samples. This is the array of training array samples, such as training data in the format required by the machine learning algorithm. Layout. There are two types of layouts: row_sample. Training samples are the matrix rows, and call_sample. Training samples are the matrix columns. Responses. This is the vector responses that is associated with the sample data. P. This is the StatModel parameter. Flags. There are optional flags defined by each method. The predict method is simpler and has only one call. It has these parameters. Samples. These are the input samples to be predicted. There can be only one or multiple data to be predicted. Results. This is the result of each input row samples, computed by the algorithm from the previously trained model. Flags. These are optional flags that are model dependent. Some models, such as Boost and SVM, recognize the StatModel raw_output flag, which makes the method return the raw results, the sum, and not the class label. The StatModel class provides other very useful methods, which are as follows. IsTrained. This returns true if the model is trained. IsClassifier. This returns true if the model is a classifier, or false in the case of regression. GetVarCount. This returns the number of variables in training samples. Save. Constring and file name. This saves the model in the file name. PTR. This loads the model from the file name, for example. Calc error. This calculates the error from a test data, where the data is the training data. If the test is true, the method calculates the error from the test subset of all the training data. Otherwise, it's computed over the training subset of the data. Finally, RESP is the optional output results. In this video, we have introduced machine learning concepts, learned about OpenCV and its operations.